Hello guys, welcome again. Today I'm going to be tackling the SQL fundamentals room from TryHackMe. Uh, yeah, that's it. Let's get to it, right? SQL fundamentals. Learn how to perform basic SQL queries, retrieve and manage data in a database. These are just data management stuff, so we'll check it out. Introduction. Cybersecurity is a broad topic that covers a wide range of subjects, but few of those are as ubiquitous as databases. Whether you're working on securing a web application, working in a SOC, and using a SIEM, configuring user authentication, access control, or using malware analysis, threat detection tools, the list goes on, you will in some way be relying on databases. Yeah. For example, on the offensive side of security, it can help us better understand SQL vulnerabilities, such as SQL injections, and create queries that help us tamper or retrieve data within a compromised service. On the other hand, on the defensive side, it can help us navigate through databases and find suspicious activity or relevant information. It can also help us better protect the service by implementing restrictions when needed. Because databases are ubiquitous, it is important to understand them, and this room will be your first step in that direction. We'll go through the basics of databases, covering key terms, concepts, and different types before getting to grips with SQL. Room prerequisites. This room has been written especially for beginners. Because of this, users with little to no IT experience will be able to follow this room without the need to complete any of our material beforehand. However, having the Linux fundamentals down would prove helpful. Learning objectives. Understand what databases are, as well as key terms and concepts, understand different types of databases, understand what SQL is, understand and be able to use SQL CRUD operations, also SQL classes operations, SQL operations, operators, and functions. Okay, yeah, yeah, these are just some tasks that we will be doing on databases with SQL, and I think this is important whenever you compromise a particular, I don't know, if you're able to get into a company's database and look at sensitive data and potentially make modifications, extract data, that's when you do the most harm to a company, right? So this is highly sensitive in cybersecurity terms. So yeah, you don't want just any eye prying onto your database. It could have sensitive data of basically your clients or the users that you have. So yeah, let's get to it. Databases 101. Introducing databases. Okay, so you've been told just how important they are. Now it's time to understand what they are in the first place. As mentioned in the introduction, databases are so ubiquitous that you very likely interact with systems that are using them. Databases are an organized collection of structured information or data that is easily accessible and can be manipulated or analyzed. The data can take many forms, such as user authentication data, such as usernames and passwords, which are stored and checked against when authenticating into an application or site, like TryHackMe, for example. User-generated data on social media, like Instagram and Facebook, where data such as user posts, comments, likes, etc., are collected and stored, as well as information such as watch history, which is stored by streaming services such as Netflix and used to generate recommendations. I'm sure you get the point. Databases are used extensively and can contain many different things. It's not just massive scale business that uses databases. Smaller scale businesses, when setting up, will almost certainly have to configure a database to store their data. Speaking of kinds of databases, let's take a look now at what those are. Different types of databases. Now it makes sense that something is used by so many. Now it makes sense that something is used by so many and for relatively so long that there will be multiple types of implementations. There are quite a few different types of databases that can be built, but for this introductory room, we're going to focus on the two primary types: relational databases, aka SQL, versus non-relational databases, non-SQL. So relational databases are table-based, and non-relational databases are key value graph, wide column document based, right? So relational, store structured data, meaning that the data inserted into this database follows a structure. For example, the data collected on a user consists of first name, last name, email address, username, and password. When a user joins, an entry is made in the database following this structure. This structured data is stored in rows and columns in a table, all of which will be covered shortly. Relationships can then be made between them or more tables, for example, user and order history, hence the term relational databases. And then non-relational databases, instead of storing data the above way, store data in a non-tabular format. For example, if documents are being scanned, which can contain varying types and quantities of data, and are stored in a database that calls for a non-tabular format, here's an example of what that might look like. ID, object ID, name, first, last, yeah, okay, date of birth, new date, occupation, the one, okay. Steps taken, number one, okay. In terms of what database should be chosen, it always comes down to the context in which the database is going to be used. Relational databases are often used when the data being stored is reliably going to be received in a consistent format where accuracy is important, such as when processing e-commerce transactions. Non-relational databases, on the other hand, are better used when the data being received can vary greatly in its format but need to be collected and organized in the same place, such as social media platforms collecting user-generated content. Okay, table, rows, and columns. Tables, rows, and columns. Now that we've defined the two primary types of databases, we'll focus on relational databases. We'll start by explaining tables, rows, and columns. All data stored in a relational database will be stored in a table. For example, a collection of books in stock at a bookstore might be stored in a table named books. Okay. Yeah, makes sense. When creating this table, you will need to define what pieces of information are needed to define a book record, for example, ID, name, and publish date. These would then be your columns. When these columns are being defined, you would also define what data type this column should contain. If an attempt is made to insert a record into a database where the data type does not match, it is rejected. The data types that can be defined can vary depending on what database you're using, but the core data types used by all include strings, a collection of words and characters, integers, numbers, float, decimals, numbers with decimal points, and times and dates. Once a table has been created with the columns defined, the first record would be inserted into the database. For example, a book named Android Security Internals with an ID of 1 and a publication date of 2014, blah blah blah. Once inserted, this record would be represented as a row. Yeah. Primary and foreign keys. Once a table has been defined and populated, more data may need to be stored. For instance, we want to create a table named authors that stores the authors of the books sold in the store. Here's a very clear example of a relationship. A book stored in the books table is written by an author storing the authors table. If we want to query for a book in our story, but also have the author of that book returned, our data would need to be related somehow. We do this with keys, right? There are two types of keys: primary key and foreign key, right? The primary key is used to ensure that the data collected in a certain column is unique. That is, there needs to be a way to identify each record stored in a table, a value unique to that record and is not repeated by any other record in that table. Think about matriculation numbers in a university. These are numbers assigned to the students so they can be uniquely identified in records. As sometimes the students can have the same name, a column has to be chosen in each table as a primary key. In our example, ID would make the most sense as an ID has been uniquely created for each book, where, as books can have the same publication date, or in rare cases, book title, note that there can only be one primary key column in a table. And then foreign keys. Foreign keys are a column or columns in a table that also exist in another table within the database. Is the one that makes the connection between two databases, right? And therefore provides a link between the two tables. In our example, think about adding an author ID field to our books table. This would then act as a foreign key because the author ID uh, in our books table corresponds to the ID column in the author table. Foreign keys are what allows the relationships between different tables in relational databases. Note that there can be more than one foreign key column in a table. Yeah. What type of database should you consider using if the data you're going to be storing will vary greatly in its format? Unrelational database. What was it? Non-relational. All right. Yeah. What type of database should you consider using if the data you're going to be storing will reliably be in the same structure format? Well, relational, right? In our example, once a record of a book is inserted into our books table, it would be represented as a ID. What? As a once a record as a row? Yeah. Which type of key provides a link from one table to another? Link, foreign key. Now, which type of key ensures a record is unique within a table? That would be primary key, right? Okay, we got it. Now SQL. What is SQL? Now, all of this theoretically sounds great, but in practice, how do databases work? How would you go and make your first table and populate it with data? What would you use? Databases are usually controlled using a database management system, DBMS, serving as an interface between the end user and the databases. A DBMS is a software program that allows users to retrieve, update, and manage the data being stored. Some examples of DBMS include MySQL, MongoDB, Oracle Database, and MariaDB. The interaction between the end user and the database can be done using SQL, structured query language. SQL is a programming language that can be used to query, define, and manipulate the data stored in a relational database. The benefits of SQL and relational databases. Well, SQL is almost as ubiquitous as databases themselves, and for good reason. Here are some of the benefits that come with learning and using use. What? Here are some of the benefits that come with learning and using SQL. I guess that's what they mean. Type alert had me confused. Okay, it's fast, yeah, right? Relational databases, aka those that SQL is used for, can return massive batches of data almost instantaneously due to how little storage space is used and high processing speeds. Okay, easy to learn. Unlike many programming languages, SQL is written in plain English, making it much easier to pick up. The highly readable nature of the language means users can concentrate on learning the functions and syntax. Reliable. As mentioned before, relational databases can guarantee a level of accuracy when it comes to data by defining a strict structure in which data sets must fall in order to be inserted. Flexible. SQL provides all kinds of capabilities when it comes to querying a database. This allows users to perform vast data analysis tasks very efficiently. Getting hands-on. Now that we've covered what SQL is, it is time to what? It's time to get hands-on and start using it yourself. Click the green Start Machine button. The machine will start in split screen view. In case the VM is not visible, use the blue Show Split View button at the top of the page. Once the machine has finished booting up, open the terminal and run the following command. MySQL, which is database -u root, so logging as root. And then what does -p stand for? Prompt. Once prompted for the password, oh, okay. Enter TryHackMe. Okay, the output should look as follows. MySQL -u, enter password, welcome to MySQL monitor, and then you are in MySQL where you can issue SQL commands, I guess. With that covered, you are ready to start using and learning SQL. What serves as an interface between a database and an end user? What serves as an interface between a database and an end user? Sorry, I don't know what you mean by that. DVMS? Yeah, database management system, right? This is what they use. What query language can be used to interact with the relational databases? SQL query language. Okay, on to the next. Database and table statements, right? Time to learn. Now the fun part. It's time to start learning SQL and how to use it to interact with databases. In this task, we are going to start by learning. Yeah, okay. Sorry. We're going to start by learning to use database and table statements. After all, it's these statements that we need to initially create our database tables and get started. Okay. Database statements. Create database. If a new database is needed, the first step you would take is to create it. This can be done in SQL using the create database statement. This would be done using the following syntax. Okay, so let's just go to the terminal. We just boot it up. What was it, if I remember correctly? It was MySQL -u, and then it was root, and then -p to have the password prompted, if I remember correctly. Might be wrong. MySQL -u, root -p, and then they prompt me for a password. It was TryHackMe, and then we're in, right? And then we're gonna be following along, create database, and then database, run the following command to create a database name, THM bookmarket. Okay. THM bookmarket DB. Is that it? Oh, we're missing, yeah. Okay, query, okay. Show databases. Okay, so do we have the one that we've just created? I think so, yeah. show databases. Now that we have created a database, we can view it with the show statement. The show database statement will return a list of present databases. In the return list, you should see the database you have just created and some databases that are included by default. MySQL information scheme, performance scheme, yeah, we can see them, and sys, right, system, which are used for various purposes that enable MySQL to function. Also present are various tables needed for this lesson. Use table. Okay, once a database is created, you may want to interact with it. Before we can interact with it, we need to tell MySQL which database we would like to interact with, so it knows which database to run subsequent queries against. To set the database we have just created as the active database, we would use the use statement as follows. Okay, use thm 0 to complete, no, book market db. Okay, database changed, so we've selected that one. Once the database is no longer needed, maybe it was created for test purposes or is no longer required, it can be removed using the drop statement. To remove a database, we will use the following statement syntax, although in our case, we want to keep our database, so no need to run this one yourself, right? Table statements. Now that you can create, list, use, and remove databases, it's time to examine how we would populate those databases with tables and interact with those tables. Create table. Following the logic of the database statement, creating tables also uses a create statement. Once the database is active, you have run the use statement on it. Yeah, a table can be created within it using the following statement syntax. So we've selected this table, this database, I'm sorry, and then we're gonna create a table on it. Create table, example, table name. Server with the table using the following statement. Okay, sorry, you're just providing me with some actual content that you would like me to have. Book inventory. And then create table, book inventory. And then we have the book ID, which is going to be an integer. Auto increment primary key. Right? And then the next one, book name, black chart 255, not null. Now publication date and then date, right? Then we can close it. Yeah, that should be very okay. This statement will create a table book inventory with 3 columns: book ID, yeah, book name, yeah, publication date, right? And book ID is an int, an integer, you can say, as it should only be ever a number. Auto increment is present, meaning the first book inserted would be assigned to book ID of 1, the second book inserted would be assigned to book ID of 2. Okay, makes sense, and so on. Finally, book ID is set as the primary key, yeah, as it will be the way we uniquely identify a book record in a table, and a primary must be present in the table. Okay, so this is mandatory, right? We just have to choose which column is going to be our primary key. In this case, it's going to be this ID, book ID. Okay, book name has a data type varchar, which is basically a string, meaning it can variable characters, text, numbers, punctuation, and a limit of 255 characters is set, and not null, meaning it cannot be empty, right? So if someone tried to insert a record into this table, but the book name was empty, it would be rejected. Publication date is set as the data type date. Yeah. Show tables, right? Just as we can list databases using a show statement, we can also list the tables in our currently active database, the database on which we last used the use statement. Run the following command, and you should see the table you have just created. Show tables. Okay, we have the book inventory. If we want to know what columns are contained within the table and their data type, we can describe them using the describe command. Describe book inventory. Yeah, and we can see all the columns. This will give you a detailed view of the table like so. Yeah. Altered. Once you have created a table, there may come a time when you need for data set changes and you need to alter the table. This can be done using the alter statement. Let's now imagine that we have decided that we actually want to have a column in our book inventory that has the page count for each book. So add this to our table using the following statement, right? So we're gonna be alter table book inventory, and then we're gonna be adding page count, and it's gonna be an integer. Now, if we do the describe book inventory. Then we have a new attribute, which is page count, right? It stands for an integer. A statement can be used to make changes, such as renaming columns, changing the data type in a column, or removing a column. Drop. Similar to removing the database, you can also remove tables using the drop statement. We don't need to do this, but the syntax you would use would be this. So drop table. Using the statement, you've learned to list all the databases. Should build a database with a flag for a name. What is show databases? Was that the command? Yeah. Oh yeah. I just found it. So this is it. Let's copy our flag, paste it. In the list of available databases, you should also see the task for database. So set this as your archive database. So I guess it's select task for DB. I'm wrong. Select. It wasn't select. What was it? Oh, it was use. Use task for DB. Database changed. Okay. So this is your active database and list all tables in this database. Show tables. What is the flag present here? Oh, we found it. This is the flag present here. Yeah, okay, CRUD Operations, right? Let's keep going. CRUD stands for create, read, update, or delete, which consider the basic operations in any system that manages data. This is everything you do, even when you have a web application and you want to basically make changes to the database. CRUD is the foundations of it, right? Whatever you're going to be doing, you're going to be, I don't know, maybe creating users, removing, reading, updating, or deleting. Yeah, those are just the four main cores that you do on a database. So this is just a must know. CRUD stands for create, read, update, or delete, which are considered the basic operations in a system that manages data, right? Let's explore all these different operations when working with MySQL. In the next two tasks, we will be using the books table that is part of the database THM books. We can access it with the statement use THM books, right? Create, okay, so use THM books. Yeah, well, use THM database changed. Okay, that's what I wanted. Create operation. Insert into books. Okay. The create operation will create a new record in the table. In MySQL, this can be achieved by using the statement insert into as shown below. So, okay, as we can insert into statement specifies a table, which is going to be books. In this case, where you can add a new record. The columns ID, name, published date, and description are the records in the table. In this example, a new record with an ID of 1. Name of Android security internals and a published date of 2014 and a description stating Android security internals provides a complete understanding of the security Okay. I'm sorry, where is that? Of the security internals of Android device of a set it. This operation already exists in the database, so there is no need to run the query. Read operations, okay. So if we gonna select from books. Okay, so you can read all the table content, right? The different books and blah blah blah. Okay, the above where were we? Yeah, the above output select statement is followed by an asterisk, symbol indicating that all columns should be retrieved, followed by the from clause and the table name, in this case books. If you want to select a specific column like the name and description, we should specify them instead of the symbol as shown below. Select name, description, from books, right? And we only get those attributes. Update operations. The update operation modifies an existing record within the table. In the same statement, update can be used for this. So update books. The update statement specifies the table, which is books, and then we create a set followed by the column name we will update. So description, you're updating the description here, the where clause, It specifies which row to update when the clause is met. In this case, the one with the ID of 1. Delete operations. The delete operation removes records from a table. We can achieve this with the delete statement. Delete from books where ID is 1, right? There's no need to run the query. Deleting this entry will affect the rest of the examples in the upcoming tasks. So the summary. In summary, CRUD operations results are fundamental for data operations and when interacting with databases. The statements associated with them are listed below. Create, read, update, and delete. These operations enable us to effectively manage and manipulate data within a database. Using the tools DB database, use it, okay. What is the name of the tool in the hacking tools? Alert from okay, hacking tools. Okay, so what are you asking me? What is the name of the tool in the hacking tools table that can be used to perform man-in-the-middle attacks on wireless networks? Man-in-the-middle attacks on wireless networks, that would be wireless, so Wi-Fi pineapple. Using the tools DB database, which is the one we're using. What is the shared category for both USB Rubber Ducker and Bash Bunny? USB Rubber Ducker, well, select, where are you asking me? Category, from where? Hacking tools, right? So you have these categories, Rubber Ducker and Bash. Those would be USB attacks, right? Connecting the dots here. Okay, on to the next. Clauses. A clause is part of a statement that specifies a criteria of the data being manipulated, usually by an initial statement. Clauses can help us define the type of data and how it should be retrieved or sorted. Okay. In previous tasks, we already used some clauses such as from that is used to specify the table we are accessing with, or statement and where, which specifies which records should be used. This task will focus on other clauses: distinct, group by, order by, having. Distinct clause. The distinct clause is used to avoid duplicate records when doing a query, returning only unique values. Let's use a select from, select, but I don't think we're using that. Show databases, is that it? Yeah, so I guess we have to use the THM books, then show tables, books, yeah, and then select from books. Yeah, and we get that, okay. And observe the results below. The query's output displays all the content of the table books and the record ethical hacking is displayed twice. That's true. So let's perform the query again, but this time using the distinct. Select distinct main from books. Yeah, okay, so now it doesn't repeat itself. The output shows only 5 rows are returned and just one instance of the ethical hacking record is displayed. Group by clause. This is basically to sort them out, right? Or group them by, as they say. Aggregates data from multiple records and groups the query results in columns. This can be helpful for aggregating functions. So if we do select name count what can I type? From books group by name. Okay. In the example above, the records on the book table are regrouped by the result of the count function, right? We already know that ethical hacking is listed twice, so the total count is 2 placed at the end since it is grouped by count. Order by. The order by clause can be used to sort the records returned by a query in ascending or descending order. Using functions like ask or descending can help us to accomplish that, as shown below in the next 2 examples, right? So if we do the same thingy, select name, select, and you're going to select all records from books order by published at date ascending. Okay, so they have been ordered by the publication date, right? Descending order, the same with descending, right? We can observe the difference between sorting by ascending order and in descending order using descend both using that published date as reference, right? That's the parameter to take into account to actually make this evaluation. And then the last one is having clause. The having clause is used with other clauses to filter groups or results of records based on a condition. In the case of group by, it evaluates the condition to true or false. When like the where clause having filters the result after the aggregation is performed. Okay, so let's check it out. Select name count, and then from books, and then group by name, and then having name like pack. Okay, so okay, just by names that have this word, right? And whatever it is behind or after it. In example, we can observe that the query returns the books with names that contain the word hack and the proper counts we learned before. Using the tools DB, use tools DB. Okay, what is the total number of distinct categories using the hacking tools table? Distinct categories. Okay. Let's select from and then for hacking tool. So we have all of this, right? What are you looking for using the tools table? What is the total number of distinct categories? Okay. Select distinct. Right, distinct. How is it? Distinct and then category from hacking tools. Okay, what is the total number? 6. What is the total number of distinct categories, right? 6. 6. Yeah, using the tools database, what is the first tool by name in ascending order from the hacking tools? By name. Okay. So that would be select and then from hacking tools order by name, right? Just said name and then ask. It's going to be ascending. What did I do wrong? Select from hacking tools order by name ascending. What did I do wrong? That's all good. Select all from hacking tools order by name ascending. Yeah. Okay, bash bunny. Using the tools database, what is the first tool by name in descending order? From the hacking tools, well, just basically run this, but with ESC. Where's that? This. Put desk. Okay. Wi-Fi pineapple. Okay, now operators. When working with SQL and dealing with logic and comparison, operators are a way to filter and manipulate data effectively. Understanding these operators will help us to create more precise and powerful queries. In the next 2 tasks, we will be using the books table that is part of the database THM books. So THM books 2. Let's just change to use this database. We can access it with the statement used, yeah. Logical operators. These operators test the truth of a condition and return a Boolean value of true or false. Let's explore some of these operators next. Like operator. The like operator is commonly used in conjunction with clauses like where in order to filter for specific patterns within a column. Let's continue using our database to query an example of its usage. Select from books where description like then contains this guide word. Okay. Oh, so these are guides. The query above returns only records from the books filtered, but the ones using the word clause that contains the word guide by using the like operator, right? Or description, like, yeah, makes sense. An AND operator. The operator uses multiple conditions within a query and returns true if all of them are true. Or it returns true if only one of them is true, right? We already know that it's basic programming. Not operator, whenever a condition is not true, right? So where not description like guide, okay. So you're gonna be, yeah. Between operator, the between operator allows us to test if the value exists within a defined range. Yeah, 2 and 4. So select books where ID between, yeah, okay, makes sense. Comparison operators. The comparison operators are used to compare values and check if they meet specific criteria. Yeah, you can equal where name equals this, and then you can check if the either stable or a record with that name. Not equal to, or if it's different than, and less than operator, just okay, we can filter them with dates, so that would work, I guess. Compressive deflection with a given value is lesser than the provided one. Okay, and then greater than, same logic. Less than or equal to, and greater than or equal to, same logic, guys. So we're not going to be taking too much time into this. Using the tools DB database, which tool falls under the multi-tool category and is used for pen testers and geeks. Okay, so let's go. Use tools DB. And now with which tool falls under the multi-tool category. Select category from hacking tools. Is that it? Yeah. Which tool falls under the multi-tool category and is useful for pen testers and geeks. Select from hacking tools where what? Empty set. What did I do wrong? Tools, which tools falls under the multi-tool category and is useful for pen testers and geeks? Pen testers or name like geeks. Oh, okay. Select category from hacking tools. How would I go about this? Let's take a look at this. Like operator, yeah. Select all from book where category is like, no, that couldn't be the case. Where category is equal to and name. I guess this would be it. Select from hacking tools where category equals multi-tools. I'm gonna have to edit that, and name equals pen test. Yeah. And then what is the name of the category that you're asking for? Multi-tool. Multi-tool. What am I doing wrong here? Use word clauses and like operators. Yeah, select from hacking where category multi-tool. And name like. And name like. I guess we have to add this. Oh. We just get this done. Just give me a sec. I'm checking out. To do this between operator like yeah. Okay, so it selects everything from tracking tools where what do you mean useful for pen testers and geeks? Select from multi-tool category. This one falls under this the flipper zero. This could this is probably the one for pen tester and geeks in the toy-like form, right? This is it. Flipper zero. Oh, I should have looked into the. It's not the name because the name doesn't contain the word, but it's on the under the description. So yeah, using the tools data, we want the category of tools with an amount greater than or equal to 300. Greater than or equal to 300. Well, what is the category of tools? That would be this one here. RFID, RFID cloning, right? I mean, I understand that I have to basically run the queries, but you know, using the tools DB database, which tool falls under the network intelligence category with an amount less than 100? Well, which tool? Land turtle. And then the functions, right? We're getting close to the end. When working with data, functions can help us streamline queries and operations and manipulate data. Let's explore some of these functions next. String functions. Perform operations on a string, returning a value associated with it. Concat. Okay. Select concat name is a type of category book as book info from books. Okay. This query concatenates the name and category columns from the books table into a single one named book info. Okay. Group concat function. This function can help us to concatenate data from multiple rows into one field. Let's explore an example of its usage. Select category, group concat name separator as books from books, group by category. Okay. Substring functions. Select substring published date 1 4 from 1 to 4 as published year from books. Okay. In a query book, we can observe how it extracts the first 4 characters from the published date column and stores them in the published year column. Length. This function returns the number of characters in the string. This includes spaces and punctuations. We can find an example below. Length of the name as name length from books. Yeah, okay, makes sense. Aggregate functions. These functions aggregate the value of multiple rows within one specified criteria in the query. It can combine multiple values into one result. Count. Count function returns the number of records within an expression, as the example below shows, and then sum returns the sum. All values not null of a determined column. Yeah. So yeah, okay. As total price, so you're summing the sum of the prices. Max function calculates the maximum value within a provided column in an expression. And then mean, the same logic using the tools that what is the tool with the longest name based on character length? We're still in the tools DB, right? Just in case. Yeah, we are. What is the tool with the longest name based on character length? Well, I mean, that would be used to be Robert Ducky. Yeah, right. I'm using the tools DB. What is the total sum of all tools? I think this is the query I will have to run. The total using the tools DB. What is the total sum of all tools? Right. So substring, no, sorry, I want to sum them up. So it's select and then I just don't know what the name of quantity amount. That's the name of this amount as total price from hacking tools, right? And then it's 14444. Using the tools database where the tool names where the amount does not end in zero and group the tool names concatenated by. Okay, what are the tool names? So there are two tool names probably where the amount does not end in zero and group, well, there are only two, and group the tool names concatenated by. Okay, makes sense. Do you want us to run this? I can run it. So let's run it. Okay, just for the sake of practicing this. So this is select. Where are we checking? Select name, I guess. Group, concat, and then name, I guess, separator, and then we're gonna have the separator, and then a space, and then this, as, and then books from hacking tools, group by name probably. Okay, we'll check it out what they're asking me here. Make the changes accordingly. So using the tools, what are the tools name where the amount does not end in zero? Okay. Where the amount, select name. Where amount different than zero. Oh, how would I do about that? I guess this, right? Does not end in zero and group the tool names concatenated by this as book from hacking tools, and then group them by name, I guess. Select all. I might have a syntax issue here, but let's check it out, right? And then concatenate them by name as books from hacking tools. And then group them by name. Yeah. What am I doing wrong? Use group concat function. That's what I'm using, but I mean. Concat, select group concat, yes. So where are we selecting? All right, we're selecting the names. Name, and then group concat, and then name separator. Oh, but where are we checking here? Tool names were the amount. Select. So this is going to be name. I'm not sure. You know what? Let's just doesn't end with zero. I copy XS. Is that it? Nope. Where the amount does not end in zero. So this one doesn't end with zero and it's the flavor zero. So flavor zero. And what is the next one? that doesn't know which here. It's this one, and it's icopyxs, right? Icopyxs. And that's it, guys. Yeah, I didn't want to waste too much time trying to figure out the command for that, but you get the point, right? Congratulations on completing SQL fundamentals. This room has hopefully taught you the importance of database in computing with so many use cases which we frequently interact with in our day-to-day lives. Learning the fundamentals is a must if you want to pursue a career in cybersecurity. To round things off, let's summarize everything that was covered in this room. Databases are collections of organized data of information that are easily accessible and can be manipulated or analyzed. The two primary types of databases are relational databases used to store structured data and non-relational databases used to store data in a non-tabular format. Relational databases are made up of tables, columns, and rows. Primary keys can ensure a record is unique within the table, and foreign keys can allow for a relationship connection to be made between two or more tables. SQL is an easy-to-learn programming language that can be used to interact with relational databases. Database and table statements can be used to create, manipulate databases and tables. CRUD operations, insert, select, update, and delete can be used to manage data in the database. In SQL, we can use clauses to define how data should be retrieved, filtered, sorted, or grouped. The efficient use of operators and functions can help us filter and manipulate data in SQL. This wraps up this room. Click the button below to complete the room. Sure. Completed. Let's just finish this. And that's everything for today, guys. Thank you for staying with me here. That's the SQL fundamentals room from TryHackMe. Peace.